I always like to start any presentation. Well, first off, thank you for coming. I like to start every presentation with just a little introduction to who I am, because that gives you kind of a sense, it's like, well, of course he thinks that way because, lay out my bias a little bit, give you a sense of where I come from. So I am a system administrator by trade. I've got a CS degree and I'm kind of backing back into the programming. Which is when you don't give me any other work to do. So this is a really great fit from my perspective. And so that's kind of where I'm at. I've been doing system administration for a little less than 20 years. And I will just lay out my biggest bias right up front, which is that having done system administration for the period of time I have, this is the biggest thing I have seen. Virtualization was interesting. Cloud was interesting. This is different. All of these other tiers of technology, we went through a change of structure, not structure, but implementation responsibility, but not kind of a fundamental thinking process. We're still booting up. First we were booting up hardware, then we were booting up virtual machines, then we were booting up cloud instances. But there was no difference here. It was really just the difference of implementation. We still had to apply patches, we still had OS upgrades and things like that. And Docker is not like completely devoid from this heritage, but it's really quite a dramatically different way of thinking. So from my perspective, this is pretty much the biggest thing that's happened in a very long time. At the very least, it's the biggest thing since virtualization took over as kind of a standard practice, or since cloud took over as a standard practice. But I might even bump it up a little higher than that. Before we launch into this too quickly, let's go ahead and start up your Docker machines. So I had you did a Docker machine creation earlier today or yesterday. And if you did the stop, everything should be good. If you didn't do the stop, might need to restart your Docker machine. I find when I put my computer to sleep, it breaks it. So I'm just going to do Docker machine start. And I actually named my tutorial too, because I have a backup in case this doesn't work. And this should get your laptop environment up and running. And while we're going ahead and discussing some stuff. So one thing before we get too much farther, since a lot of you either haven't worked with Docker before or you didn't see my previous Docker talk, there's some terminology that can be really perplexing and a big stumbling block. I find it was very difficult for me to get over some of this terminology. I found that when I introduced other people to Docker, they've gotten very confused by this terminology. So I'm going to cover a little bit there first. I'm not going to get into the meat of it yet. The first thing is, I just want to put out an analogy here. We're all Rubyists, except for myself. I'm actually a Python person. I know you can beat me afterwards. But I want to just bring out this analogy of classes to instances, right? You have a class, you instantiate it, and you have an instance at runtime, or an object, or depending on what language you're talking about. Let's call it an instance. And there's a bit of that relationship. It's not a good analogy. There's a lot of rules that get violated, but it's a sufferable one. And so in Docker, we have images. And when you instantiate them, you run your image. And that creates a container. So a container is something that has state, that's running. And an image is something that's read-only and static. It is used to create containers. With that out of the way, another thing to consider is just what an image is and how an image and a container differ from each other. So images are made out of layers. The best kind of analogy I can think of is acetate sheets, the clear sheets people used on overhead projectors. You could write something on the sheet, and then you could lay another sheet with something written on top of it, on top of that. on top of that. And so what you would see projected on the wall would be the accumulation of those layers. And so you might have a base layer, and then you'd have a change from that, a change from that, change from that, and change from that, and then you have this final view overall. And so you get something like that with the way an image is built, where it's built up of all of these layers. And those layers are cryptographically hashed, so it's not as if like these layers can change underneath each other. I inherit from this collection of bytes a hash, that's hashed out to this value. So if you change the underlying layer, you diverge, you create another tree of dependency. But you have these layers. Now, there's a couple of gotchas with these things. Whereas the acetate sheets, if you put one on top of each other, you can't erase something from below. In the layers in these images, you actually can. In AUFS, which if you haven't looked at that technology, they call it whiteout. So you can white out a file. You say remove file. So that means is you have a base layer, you've got maybe your OS install, you've got your application install, and your application install, you decide to delete a file in the operating system. It'll just mark it as there's nothing here. It'll still exist in the lower layers, but it's now in its assertion that there's nothing there. So that's one difference. And actually, that's all I'm going to get into with that. But when you take an image and you make a container, what you actually do is you take the image and you create another layer on it. And so what you do, actually the best way to say is that you create a layer that lays on top of an image. And that layer is a read-writable layer. So you can make changes to that layer. It doesn't touch the underlying images. So if you have, say, 60 containers, they're all based off of the same image, and they all blow away the file system, the image is still there. Each one of those containers has to blow away the files independently in their read-write layer from the other containers. So hopefully that makes sense. It has a lot in common with Git and how you have branches and so forth, except that you don't really merge in the same way that you do in Git. But branching out is very similar. So with that, does that sort of make sense? I want to just dive into the Docker part, but I got everybody? Okay, cool. So let's go ahead and jump into our Docker kind of VM. So I'm going to do Docker machine tutorial and SSH. Or actually, I think it's SSH tutorial. But again, I've renamed mine so it's tutorial 2. So you should all see this on your screen. The boot to Docker logo. And you should have a directory called tutorial. Does everybody see that? Cool. Awesome. We're ready to go. Okay. So the first section, I'm just going to cover some basics. And the first thing that you're going to want to do, so Docker creates these reusable, or allows you to create these reusable images. And so you can say, I create an image that does blank. And then you can say somewhere else, well, I want blank with this little tweak. Or I want blank as part of this constellation of things that are working together. And so a really important part of this is the pull. So this is, if you aren't on the network, by the way, this would be a good time to join the network because your polls won't work otherwise. But this is a way for you to benefit from other people's implementation of things. So rather than going to your server and installing MySQL and getting it running and installing its dependencies and so forth, you can just pull an implemented MySQL server. And yeah, you have to learn a little bit about the interface, but it's largely been packaged and tuned to function well already. You don't need to futz with it. You don't need to jump into the etc defaults directory and say, yeah, no, I actually do want to run it. I did install it. So to that end, I'm just going to have everybody here practice one poll. And we're going to do a Docker poll hello world. So Docker poll hello world. There's a dash in there. And what we're going to see here is, remember I was talking about those layers. So we see that it pulled 2 layers in here. And it has a cryptographic sum that says all this stuff adds up properly. And now it's available. So what's interesting is now I have an image in my computer. It hasn't done anything. You've got to instantiate it or run the image in order to have some sort of service or function. So this just copies bytes onto your machine. It doesn't actually do any kind of work outside of that. So Docker run is how we run images. So Docker run hello world. And we'll see that we've run this thing, and it says hello from Docker. It's got some stuff, tells you, it tells you what's going on here. And this isn't terribly interesting, except that now we've downloaded somebody's implementation of an image called Hello World, and we ran it on our computer. And I deliberately chose this one because it's incredibly tiny, so it doesn't do anything useful. I think it's like 960 bytes or something silly like that. We can't do useful things in that little space anymore.
Sorry, is it both be guest or what's the
go with both and then the passwords.
Yeah.
So, like I said, we downloaded an image. So let's go ahead and how do we look at our images? So if you type Docker images, you get a list of all the images. And these are the images that I have on my machine. You might have some on your machine. Now, one thing to keep in mind, I tried to make this presentation more exciting by not making us sit around waiting for 10 minutes for things to build or for stuff to download. So when you did your setup process, I downloaded a whole bunch of stuff onto your computer right up front so you didn't have to do it here. So we've got a bunch of images already. You can see I have this Hello World image, which we just downloaded, 960 bytes. We have Ruby, which is a bit of a porker. MySQL, we have something that doesn't have a name. And we have this to-do chapter 6 app, a bit from the future, we'll say. So let's see. One thing to note about the sizes over here. These are the sizes for an image that is summing up all of its layers. So if you have 2 images that are based off of another image or the same layer, what you'll see is that gets double counted. So let's say you make a implementation of a service called food, and it's a gigabyte for that service. And then you go ahead and you say, okay, take foo, and I want to run it in test mode, and take foo, and I want to run it in production mode. And so now you'll have these 2, the test image and the production image, and those will each say that they're a gigabyte plus. But the reality is they're both dependent on the same 1 gigabyte block. So don't take the sum of these as the amount of disk space you're using. I just want to warn you, because these numbers are a little weird. This is the sum of if you went from a blank machine, you needed to download everything. So how do we find stuff we want to use? Here I showed you Hello World, and it's of course completely useless. So if you want to find stuff to use, there is a website, hub.docker.com, and this is you can start, and the term is a repository. So you can create your own repositories. Docker has a public repository, and so this is a good place to look for stuff that you haven't written yourself. If you're in a corporate environment or something like that, you might decide to run your own private repository to store your stuff in, and to cache public images in, so you don't. You're not dependent on the internet, but this is the public one. So I'm just going to go ahead and look for MySQL because we're going to use that later. And there's a few things to observe here. So there are quite a few MySQLs. Anybody pretty much can stuff something up here. So yeah, that's as worrisome as it sounds. I'm going to skip over that. But there are some that are official, and these are ones that kind of, I don't exactly know the full relationship, but essentially the Docker company has agreed to kind of let vendors in and give them this official flag and have have a more managed relationship rather than the wild, wild west relationship. So MySQL actually does have an official package maintained by the MySQL folks. And so if we go in here, we can see this is how you get the MySQL package. Don't run this right now because it'll kill the network probably. And down here, you're going to see a lot of documentation. Not every image has great documentation. The official ones generally do, so that's part of the reason why I'm showing you. And it'll have lots of information about how to run it and how to solve certain types of problems, how to manage your data and so forth. It'll also, oftentimes right here, it'll show that there's actually many versions of this. There's a 5.5.48, there's a 5.5, there's a 5.6, a 5.7, 5.7.11 actually. And so there's a lot of useful information here. So what I'm going to have us do is pull down 5.7.11. The reason why I'm going to have us pull down that version is because I've already cached that in your computer, so we won't kill the network. And so we're just going to do another Docker pull. We're going to do MySQL. And the thing to note is you type the image you want, and if you don't type this colon here, what it's going to do is it's automatically going to append a latest. So I don't want that to happen, so we're going to be explicit, and we're going to put in a 5.7.11. And so the part here, the part at the beginning is the MySQL. That is the name of the image, and this is a tag. And so an image can actually have multiple tags. In this case, the tag is 5.7.11. And you can actually take an existing image, you can add some tags or remove some tags. And so you can kind of think of this as a version number, except it's not that constrained. Your tag could be 5.7-works and 5.7 don't know why it doesn't work. So just keep that in mind. But we're going to pull down 5.7.11. And like I said, I already warmed up your computers, so what you'll see is that this actually pulled down a bunch of images, or a bunch of layers. The MySQL one is based on a whole stack of layers. And Docker is very smart. It checks the checksums online. And so what it does is it goes online and says, hey, I want this image. Do you have this image? Yes. How is the image built? Give me a catalog. And it says, well, it's made of these layers. And then it says, hey, I got these layers. Okay, thank you. I'll have a good day. Or, no, I am missing a layer. Can you send me a layer with this identifier?
Would it be correct to think of these other layers that are beneath MySQL as dependencies that MySQL needs, or is it something else entirely?
Yeah, it's they're kind of snapshots of file systems, and more specifically, they're deltas on file systems. So the base layer is empty, and then this is a delta to add this, a delta to add that, a delta to add that. And then once you've accumulated all of them and you're running them and you're looking at them, and from the top down, you see the sum of all of those deltas. Does that make sense?
Yep.
So yeah, if you're missing a layer lower, then it doesn't have a sensible delta to work against. Now Docker 110, or was it 110? Yeah, 110. Changed things a little bit, so the deltas are actually checksum themselves. You theoretically could make the same change based off of two different base images, and they would be interchangeable back and forth between them and shareable because it would be based off the checksum of that layer. The older Docker repository format, it was more tree structured. So just keep that in mind, but you probably don't need to know that. You can just assume a tree structure and it will work. It'll just be surprisingly more efficient. If we do a Docker images, we see there's MySQL, and you can see how it's listed. So it's listed with the name, the tag that's applied to it, and image ID. And this is interesting. This image ID looks kind of similar to a Git commit, and it is very similar. This is how Docker thinks of things. The same way computers think of us in terms of user IDs, and they're just nice enough to present us our username when we ask them. Docker is the same way. It's happy to, as you see from here, this thing doesn't have any name, doesn't have any tags, but it has an image ID. So you could run it. You could just run it by image ID. And I think I'm going to do that a little later. So before we get there, so let's go ahead and fire up an image. Let's fire up MySQL. So this is kind of a long command, and what I'd say is, as you get into Docker, you're probably going to want to script some of the more common, like, oh, I restart this container all the time. You're going to want to script that, like, because these lines can wrap a lot. So Docker run DB server, the MySQL root password, and this is important. You got to get this right. This is in the documentation. They say you got to set the root password or it won't work properly. And I'm just going to give it a password because I'm an idiot. And the -D is a little magic here. It's saying run in detached mode. When this container runs, don't connect standard input, standard output, standard error to my terminal at all. Just run it in the background. And that's really important, otherwise you can kind of get locked into the program. You end up having to do is kill it and then restart it in detached mode. Or sometimes you can actually get locked in this weird scenario where you can't send Control-C, you can't actually kill it, so you have to go to another screen, kill it from there, and then you restart it. So just be warned about that. You might want to run a container in attached mode, and I'll show that a little later. But we're going to start with detached mode. So I'm running a container here, and I want to give that container a name, DB server. I want to pass it an environmental variable, and the environmental variable is MySQL root password, and I'm going to set that equal to password. I'm going to run it in detached mode, and so what you're saying is this Docker run a whole bunch of arguments if you have them, and then the last two arguments are the image you want to base this thing off of. So you're going to run a copy of blank, in this case MySQL, and the very last thing is optional, and it can be some sort of command that you're going to run in that container. We're not going to add a command to our container right now, but we'll do that a little later. So just realize there's another argument there that's quietly ignored. Okay, so let's just hit run. And I used the wrong name. I should have actually used 5711 like this. Sorry about that. But we all downloaded recently, so we all got the current image. Okay, so what you'll see is that in this case it actually was overeager. It said, "Hey, I see you didn't specify the tag. I'll see what's latest and download all the layers." Coincidentally, all those layers are already downloaded, and then it just fired it up. So it'll actually, if you ask for it to run an image you don't have, it'll go try to find it for you and run it. So it'll do an implicit for so it's you can kind of ignore this part up here. Really, what we care about is this, because it's saying, okay, I ran it, and here's what I call it. It's terse, it's nice, it flows right off the tongue, doesn't it? But again, this is how Docker thinks of things internally. So let's go ahead and take a peek at this thing that's running. Remember I showed you downloading an image, and then I showed you how to look at your images. So we just ran an image and created a container. So how do we look at our containers? So Docker PS is how we look at our containers. And this shows us all the containers that are running. And so we can see this right here, the 94, kind of looks like the beginning of this, a lot like Git again. So we could actually go ahead and refer to it by this name, or we could refer to it by this name over here. This is a nice name. This is the name that it really uses internally. We have Docker PS here, but we can, let me just roll this up to the top. We can also type Docker PSA. And so what's interesting about PS is that it shows you the things that are running. PSA dash A, sorry, you can see the command here. That shows you everything, including the things that have stopped. So containers have state. They can be running and they can be stopped. They can exit and still be around. So that data, that read-write layer is still there, it's still available. You can actually restart it and have them run. Or you can blow it away and delete it and the image still remains. So just keep that in mind, that container has kind of some runtime states and meta information that an image doesn't, and it doesn't disappear automatically. You have to clean that up. So it's important to do this Docker ps-a every so often just to get a feel for, what's going on. Or, for example, if you write a container that you've got a problem, it starts up and immediately crashes, then you'd be like, "Ooh, what's up? Where's my container?" And ps-a will show you, oh, hey, my container exited. And in fact, we have one that exited here. You can see this image right here. And I apologize, the line is wrapped a little bit. Let's see, can I make this smaller? Yeah. Can you read that? Probably not. But you can see, this is the hello world image that we ran previously. So I'll just make that bigger again. And what's interesting about it, here our container name is DB server. Here our container name is clever easily. And what Docker will do is if you don't give it a nice name to call the container by, it'll make one up for you. And they're usually a lot more I'll say, curious and interesting than helpful. So that's why I passed the -- name parameter, is because that allowed me to give it a name that had some meaning. But if you don't, it will come up with one for you. So let's go ahead and let's clean up. So let's do a Docker remove. So remember how I said that your containers, you have an image and then your container has like this state information and this read-write file system layer and so forth. If you want to clear that stuff out, you want to say I don't need that work product anymore. I'm done with it. You can type docker rm and then the name of your container. So in this case, we have a container called hello world. Oh no, yeah, we have a container called hello world. So let's go ahead and do that. And it didn't work. And that's because I mixed it up. Our image is named hello world, but our container is named clever easily. So as you get a feel for it, this is why things seem a little random. Images are not containers. So let's go ahead and actually do the right thing and remove the clever easily. And if we go ahead and type docker ps -a, we see it's gone now. So everybody got that? Cool. So let's go ahead and look at one other command. So we've looked at docker run, we've looked at docker ps. So another command, and docker remove to remove container. But now let's look at docker logs. And so docker logs, and let's look at our DB server that we ran a little while ago. It's still there. By the way, if your container has exited, you can still look at its logs. They're still there. They're part of the state information. So it doesn't need to be running to look at the logs. And so that's a lot of output. So let's go ahead and pipe that to less. Where did my output go? So this is a tricky little bit. Who here... I don't have a feel for the room. Standard output, standard error, standard input. Do these things mean things to you? Raise your hand. Good. Okay, cool. No explanation needed. Less captures standard input. So Docker will actually take the output from the container and separate out the input and the error and replay it back at you in order over the correct channel, over the correct file descriptor. So if you want to see it all, you're going to have to take your 2 and 1 And then now you can get your standard error and your standard out. So most of the stuff was outputted to standard error, so it scrolled by and then less popped up over it. And so now I've mixed the two together, and we can see here's the MySQL image firing up, and actually it does this weird thing where it sort of starts twice, because it says, oh hey, my database directory isn't initialized, I'm going to go initialize it, and then what you'll see down here is the initialization's done, I'm going to start up for real, and then it starts up for real. Now if you run it again, it'll say, oh hey, I see the database is already created, I'll just go straight to starting back up. But so this is logs, so this is how you can see your output. And the way Docker works by default is it just says, we're going to run a program, we're going to run a command, and whatever comes out in standard out, standard error, that's your logging, that's your output. And so it's not like some weird syslog engine or anything weird like that. It's just if you want to log something, printf or print or out, sysout, right? It's been a while since I've done Ruby. Sysout?
Puts.
How do you print to the screen?
Puts.
Puts, thank you. Yeah. It's been almost, not almost a decade, 8 years or so since I did a lot of Ruby. Okay, so we're looking at the logs. Let's just do another docker ps all. We can see there's the DB server. And just for the heck of it, I'm going to go back up through the history, and I'm going to replace this word DB server with the ID. You don't have to do this, but Docker logs, and just do the ID. You see, you get the same thing. So, the DB server is a nice name for the actual container name. You can always use that container name in place of the pretty name. So now we've covered Docker run, how to run an image. We've actually covered pull, we've covered images. So pull, get an image, run images, look at my images, and you can actually do some management commands there too, but we're not going to talk about that. We did a Docker pull a Docker run to run an image and create a container essentially. We did Docker PS to look at containers that were running or had stopped. We did Docker remove to remove a container, logs to look at the output from our container, and now we're going to do a Docker exec. So Docker exec is a command that runs something inside a container. So your container will fire up and it'll have one program, ideally, sometimes more than one, running inside of it. And Docker exec adds another program inside that container. So I don't use this very often for kind of production-y stuff. What I use this for is development and troubleshooting. Because you're like, okay, there's some state inside that container. There's a service running and there are things interacting with other things and it's not working. What's going on in there? And you do what you would do. You jump in, you tell net to port 25. Oh yeah, the mail server's running. Okay, so that's not broken. Let's cap this config. Oh yeah, I see the config file was bad. Okay, I need to fix that in my build to create a new image that has a proper config file. We use this a lot. I use this a lot. So the first thing I'm going to do is Docker DB server. Docker exec DB server. So I want to run exec. I'm not passing any options. I'm just saying I want to run exec on a container named DB server. And then you notice that format's a little different. When I do a run, I say run, some arguments, an image name, possibly a command. Here, I'm not giving it an image name, I'm giving it a container name. So each command can be quite a bit different. You can sort of strip off the Docker at the beginning and have like a whole, reasonably long list of commands to play around with and study, but you don't need most of them to get along. I use maybe 5, 10 of them, and that's about it. So we're going to use the exec command here, though. So Docker, I want to execute something in DB server, and the command I want to execute is ps-ef. So I just want to look at the processes. And this will be, if you haven't worked with Docker before, this is going to be a little curious. I got MySQL running as PID1. And I've got this PSEF running. And so this is what's inside the container. The way Docker works is that it contains the execution environment. So containers can't see outside themselves. They can only see what's running inside themselves. They get their own process space. So if I look at my computer, I'm running a whole pile of stuff. Or actually, this is not my computer. This is inside the tutorial VM. But inside the actual container, there's only one thing running, which is MySQL, and then this other process, which I just happened to inject in there. So, okay, that's cool. So if you're running, you're like, okay, what processes are inside my container? You can type this. You can type a lot of commands. What's the date inside the container? It shouldn't be particularly different. But really, where you get into the meat of it and you get into useful troubleshooting is I'm going to pass some options. So I'm going to type docker exec space -t-i. So actually, I'll be explicit here. So what T says is I want to allocate a terminal. I want this command to actually be hooked up to my terminal directly. So detach says don't connect it to my terminal in any way. This says absolutely connect it to my terminal in every way. And then the -i says hook up standard input so I can send commands into there. So we're going to go ahead and do that, and then at the end of the line, I'm going to give it a command. Because just like run has this invisible little thing on the end where you can pass a command, exec has also that, and it makes no sense to really run an exec without a command. I don't think it would work. And so the command I'm going to give it is bash. And so now I'm running inside my container. And I'll do a ps-ef. And it looks like the PSs I was doing before. And now I can go ahead and troubleshoot. I could go ahead and, let's see if this works. MySQL user root. I didn't try this before. Hey, it works. So I could go in there, I can play around with it, I can change files, I can look at the file system, figure out WTF, why isn't it working, type stuff. And so this is very helpful. The thing to note is if you don't set a hostname deliberately, this value here is special. This is again that same container ID you saw in the external PS, in the Docker PS. So if you're a little confused on where you are, you can always look there at the hostname in there, or I'll just type hostname, and you can see, oh, okay, now when I exit out, Docker PS, and there's my hostname. So this is really great for troubleshooting. I use this all the time, like a lot. I was using this an hour and a half ago, troubleshooting a problem. And so, okay, so now we know how to run a container and how to run arbitrary stuff inside a container if we need to. So last thing we're going to do is docker rmi. So remember how I said docker rm removes a container, but what if you want to remove an image? And images are different, so there is a rmi, remove image. And let's just get rid of hello world. And it deleted it, and if I do docker images, you can see it isn't there anymore. So that's how we delete an image. So does that all make sense? Everybody following along here? Okay, cool. So section 3. So now we're going to start getting into where there are some examples, if I'm not mistaken. Yeah, so let's go into the tutorial directory. And you'll see an examples directory. And in here, there are subsections. So we're about to jump into section 3, playing with container. And you see that there's some files in here, and the script. That's what I'm reading off of here. Just my notes to myself. You can read it if you want. Nothing interesting there. So let's go back and let's try running a different container. Let's do a docker run and Debian Jesse. So, spelled like this. Does everybody have that? Cool. So we just fire this off. And what it just did was download Debian Jesse. Now, if you're wondering why that happens so fast, it's a good question, because if you look up here, we don't have Debian Jesse installed. I don't see a copy of it, but let's go look. Let's look again. Maybe I not Dicker, Docker. I swear I type that all the time. It's awful. Docker images, and there it is, Debian Jesse. So where did that come from? Well, you remember how I was talking about things are built in layers, and this collection of containers that I had you download was not like haphazardly pulled together. I deliberately chose containers that were based off of a common base. So almost all of these containers are differences on top of Debian Jesse. So what Docker said was, hey, Docker Hub, what does Debian Jesse look like? Debian with the tag Jesse look like? And it said, oh, it's made of these layers. It said, oh, hey, cool, okay, I've got those already. I'll just go ahead and note it. I'll make it visible. And so if you look on your system, there'll be dozens and dozens of layers that don't have any exposure through this images view. They're there just as supporting figures for other layers that are visible. So just keep that in mind that you have this weird stuff. So we did this Docker run Debian Jesse, and let's go ahead and see what's going on. Docker PS, and it's not running. So it must have stopped or crashed, right? We created a container. We got a container ID when we ran it, right? Let's see, where is it? Downloaded image. Oh, actually, it didn't print the.
I think you only downloaded it.
Did I do doc? No, it ran it. It should at least. And there it is. I just expected to print the image ID. So here's our image. It's called Prickly Saha. So container ID.
What is the difference between PS and PS-A? What is it
So
differentiating those on?
PS shows you containers that are in the state of running. PS-A shows you containers irregardless of their current state. So if they've crashed or stopped, or I guess it could be another pieces. I don't know if PS shows you containers that are suspended. You can actually pause a container. This is a little known C group function, which will kind of weird you out, but you can just take a program and say, wait, okay, start again. Probably not good for anything that's got a network connection, but you can do it. And so, does that all make sense? Mm-hmm. Cool. Okay, so our container was running, and we see we're running the image Debian with the tag Jesse. It started a couple minutes ago. It exited a couple minutes ago, so the state is exited rather than up. And it's got a name. But the thing that's interesting here is this command. So the command that Debian Jesse has, if you don't tell it what to do, it by default just runs bash. And since I didn't allocate TTY, didn't allocate a terminal to it, bash's reaction to not having a terminal and not having any input is it exits. It says, well, I can't interact with anything, and I wasn't told to do anything, so I'm going. See ya. And so that's why our container isn't running, is we didn't actually tell it to do anything useful. So let's, some containers have, for example, this container, the MySQL container it runs this script called entrypoint.sh space MySQL. That runs a service, and as long as that service, that command is running, the container will be in a running state. And when that command exits, the container will stop. So one of the cool things about Docker is you can you can say this container should always be running. Restart it if it ever stops. And it'll just bounce it. And so you can get rid of Monet if anybody here uses Monet for their code. Everybody writes perfect code here, I'm sure. But Docker will do that for you. And it does keep a counter on how many times it is restarted it, which would be a good thing to plug into your monitoring infrastructure. So let's go ahead and do a Docker run. We're going to run that same container. So Debian Jesse. Actually, I'm going to give it a name before that. So I'm going to pass the -- name Jesse. So Docker run -- name Jesse. And let's see, I'm going to run it in detached mode so that it doesn't hook up to my screen in any way. And I'm just going to put in a sleep 1, 2, 3, 4. So it fired up container, Docker PS. We can see it. It's running. It's called Jesse, and it's running sleep. So this will run for 20 minutes. So why don't we go ahead and just jump in with our exec command as we were doing before. Or sorry. Actually, it's a different example than I was thinking. So let's do a Docker run -ti Debian Jesse bash. So now in this case, we've actually not run it in detached mode. We've run it in attached mode. We've said allocate a terminal, set it up as interactive, and run bash. So we're actually in our Debian Jesse box. And you'll notice that, so I took the same image and I ran it twice, but I can't see that other image. Each container has its own process space, its own networking. It's independent except where you choose to expose containers to each other or to your OS. By default, they're isolated from each other. This is just kind of an interesting example of how that happens. So I'm just going to go ahead and exit out of this container. Now, what's interesting, we look, there's our Jesse container, it's still running, so I just did a Docker PS. And when I do a Docker PS all, we can see that container that let's see, where is it? This one right here. So I ran that copy of Debian Jesse with bash, and you see that it exited. So the command that I ran was bash. When bash exited, container exited, and it's now in a exited state. It doesn't go away. You got to remove it if you want to get rid of it. But that's good in the sense that maybe you want to go ahead and look the logs or do something else with it, some troubleshooting, or you could actually do a Docker restart container that might crash. I'll show that a little later. But let's see, what else am I doing here? I just want to show you one little thing that's kind of just curious. So if you do a ps-ef, so this is all the programs on your computer, right? Or in your virtual machine that you're using. And let's grep 1, 2, 3, 4. And what you'll actually see is that there's that sleep command that I ran inside the container. So if you're inside the container, you can't see outside. But that doesn't mean that things outside you can't look in. So just keep that in mind, that it's kind of a hierarchical security model. Kind of thinking like file system security, right? If you're a user, you can see your files, but nobody else's. But if you're root, then you can see your files and everybody else's, and so forth and so on. So just keep that in mind. That's how it works. So we've done a few things, but it's still not quite useful yet. So let's go ahead and start putting stuff in our containers so we can have our containers, say, run our programs. So coincidentally, in this directory, I have a directory, right, dir, which has got a file in it, and I've got this file called test file. If I cat test file, it's got I am a test file. That's really exciting. So let's do a Docker cp test file. So what I'm saying is I want to copy this file from the system into, and then you have to give it a container name, Jesse slash, let's see, where I'm just going to put it in the home directory. So if you used SCP, the syntax is very similar. It's pretty much the same thing. And so I copied test file into that container. So let's go ahead and docker exec Jesse cat test file. And you can see inside that container, I ran the command catted the test file, and there it was. Or I can do docker, I can do the same thing, ls in the root directory, and you can see, here are all the directories, and there's test file. So I just copied a file into my container. So now I can use it in that container. Things in that container can see it and change it, and that's lovely, and the world's beautiful. But sometimes we want to go the other way around. So let's go ahead and do another docker copy operation. But this time, I'm going to reverse it. This is a lot like SSH. So I'm going to copy etc, let's see, hostname? Host name. I know how to spell. And I'm going to just copy it into the current directory. So now I just copied a file out of there. And there's that file, hostname. And you can see there's that hostname. And if I do a docker ps, you can see that matches the hostname of the Jesse container that I was just playing with. So, so I can copy stuff into my container, copy stuff out. So this is really good if you're like troubleshooting. You're like, oh, there's a file in there. Maybe you're accumulating something on disk. You're like, well, let me just grab that so I can inspect it externally with my fancy database viewer or something like that. You grab, say, a SQLite file and then open it up in your SQLite viewer, rather than having to fiddle around with it on the command line inside your container. So you can copy stuff out if you need to, or you want to back it up. You realize that you have something in there that's actually of value and you want to grab it. You can copy it out. And there's a bunch of commands you can actually, you can copy all the files out. You can archive them. You can do all sorts of things. You can take a container and actually turn it into an image. I don't recommend doing that, and I'm not going to show you how to do it because a kitten dies every time you do that. But you can do it, and kittens do occasionally need to die. So if you need to, so be it. But I'm not going to show you. I'll show you a better way though. So we can copy stuff in, we can copy stuff out, and that's great. You're like, that's sort of a pain in the butt. Like, I'm going to do this at scale? No. This is not how people do things. This is more for troubleshooting. So you'd probably want to run it a little more like this. So I'm going to type docker, and I'm going to do a run, and I'm going to pass it this RM option. So what this says is, you notice how when my containers exited, they were still there. I had to kind of remove it. -RM says, when this thing quits, get rid of it. Just clean up for me. Don't leave it behind. So be careful with this. If you're going to have any useful data inside your container, you don't want to run this. But if you've got a no residue container, a container where you don't care about what's in there, your state is being maintained, say, in a database, then run it with the RM so that it cleans itself up when you're done. Or if you're just doing like a one-off command, firing up bash, looking in there because you want to see, what the image looks like inside. But when you're done, you don't need to save it. You're exploring. RM is great. So RM, and I know this is a little fast because I'm introducing now another option. So I introduced RM. I'm going to introduce V, and V is the volume command. And what it allows you to do is map spaces from outside your container to inside your container. So bind mounting. For anybody here who knows what I'm talking about, that's what we're talking about. For everybody else, it's not some weird S&M practice. It's how you mount directories into other places. So I'm going to do a PWD. And the reason why is that when you do this volume mapping, you have to give it an absolute path in the host operating system. You can't do relative paths. So pwd is where I am currently. In fact, I'll just type it just to prove. So, okay, so docker run remove volume pwd. So pwd, so mount my current home directory /dir. You see there isn't a trailing slash on this, so I'm gonna add a trailing slash and then the directory dir, which if you look up here, you can see in my home directory there's this directory called dir, and I am going to pass it a colon and say mount this. Let's see, on /mount, because I'm a Unix guy and this is how I think. I'm going to run this in TI mode, so interactive mode, and attach it to my terminal. And I want to run the container Debian Jesse. And you see why I say you want to script these eventually? Because they do get pretty long. This is not nearly the longest you'll see tonight. And I want to run bash. So that's a mouthful. Docker, run a container named Debian Jesse over here. Remove the container after it's running. When you run that container, take the directory dir and stick it inside the container at mount. And I want to, when you run that container, I want to interactively interact with the bash command. Okay, so now I'm inside my container. Woohoo! And if I go ahead and do an ls on mount, you can see that I've got a directory called mount, and I've got a file in mount. So mount file. I'm inside dir. Woohoo! So now this is great. So what you can imagine, now we've sort of got something useful. You have your MySQL container, but that's just the code. That's just a thing running. But you want your data not to be inside your container. You want your data on your host machine so it's durable, so that if you destroy the container, that data is still there. And then, for example, you might go to MySQL 5.7.12. And so you just stop the old container, you fire the new one up, and in both of the containers, you just pass the volume flag to mount that var lib MySQL to some directory on your machine.
So is this how you configure your container? If you want to override the default?
Yeah, I feel like you could, for example, have your application say /config is where my configuration files are, or import them from there. There's some better ways to do that, which I'll get into, but yeah, this is definitely, I do something kind of like this. So when you're running in multiple environments, this is a common problem. I want to run my code on my laptop, then I want to run it in my test environment or staging environment, then I want to run it in production. And each of these things are a little different, but I don't want to change my code and put a big ugly if test. How many of us have done that in our config files? If test then behave differently than if I'm in production, and then you're always like, oh God, I hope that doesn't introduce a bug because I'm totally, yeah. So rather than doing that, what you can do is say, I'm going to just put the critical attributes, like where my database server, in a file on the local machine. And so when I fire up this thing and I mount that config directory, then boom, it knows how to behave in that environment. And so on your laptop, the database server will be on some local host thing or something like that, and your production environment will be your RDS server. I've done this before. Does that answer your question? There are some better ways to do this, and I'll get into those later on. So it is a good question. You're about 10 yards ahead of me right now. So let's go ahead and I'm going to go ahead and edit that file. So back to this file, mount, and then file. Oh, VI isn't there. So these containers can be kind of light, right? They don't have much in them. I could apt-get install VI, but I'm not going to do that. I'm going to echo I am in a container. And I'm going to stick that in that file. Mount in file. So if I cat mount file, I'm in a container. Okay, so let's get out of this container. We're back on that host system. You can see we've exited out. We're sitting in the examples directory again. We're sitting here with our files, and if you cat in dir that file, you can see I changed it. So it was inside the container, I changed the thing outside my container. So now my data is outside. And you can mount any directory you want to anywhere else. You can use this option multiple times. You can say mount there. So you might have a config file system or a config directory that you're mounting in, and then you might have a data directory that you're mounting in. Now you can even mount an individual file. So you could say, take this file and put it in the file system in this part. So this is pretty reasonably flexible. But what if you want to do something like you get your web server, you get your SSL certs, and you don't want those SSL certs to be overwritable. The web server has no business overwriting them. It just needs to be able to read them. So you can actually be explicit. By the way, just a quick one, Docker PS all. You can see, look, no residue. It deleted itself. So we're going to run this again. We're going to go back up here. So that run command that we ran a few minutes ago, I'm going to save you some typing. You can just bring it back up in the history. And we're going to add another colon and RO. And RO stands for read only. So now we're going to do that same thing. We're back here where we were. Now you'll notice that I don't have any history, right? We threw away the container. The bash history was in that container. So we threw away our bash history from our previous run. This will be frustrating and annoying. You'll get used to it. But we'll go to mount cat file. It's still, I'm in a container, so echo hello world to file. Nope, can't change it. So I can read it now, but I can't change it. So that's just kind of a little bit about mounting directories from your host system inside your container. You can do this with files. So for a config file, for example, you can totally do this. But I'm not going to get into that. That I will leave as an exercise for you to work out. So we've mounted some directories. We've copied some files in. We got a bash shell. So this is all great and dandy, but it's not super Docker native. You're mounting part of the file system into Docker. One of the cool things about Docker is, and this is relatively young, but they're rapidly moving into this direction, is that they're starting to add plugin interfaces. So Docker, in your container, you have a networking interface, and you can define how networking works so that, for example, two containers that are running on different machines can refer to each other as local hosts and feel like they're locally connected. Or so that, for example, when your container writes a file, its storage is abstractable. Oh, I can store things on the local machine, as we did with that volume. Or, no, I want to use a driver that stores it in a VMware software-defined storage system. Or I want to use an NFS mount, or I want to use GFS, or any of a bunch of other storage backends. I'm not going to show you those. Those are worthy of their own presentation, which I will not be giving because I don't have access to all that infrastructure. But what we're going to do is we're going to use a Docker native storage system. It'll just kind of work smoothly, but it'll be a little bit annoying to get at your data. So you decide how you want to work with your data. But I'm going to give a demonstration of this. This is how I'm tending to do things now, because it makes it easier to do deployments and updates and things like that for me, but it's your use case. So Docker has the volume command. And if you type Docker volume, it says you can do things. So we can do Docker volume ls, and we can see that there's a volume that's been created on the local machine, and it has a nice name. Yeah. So Docker, if you don't give it a name, it'll make one up. But we're going to create a volume for ourselves. So Docker volume create, and I'm going to create a volume and name it data, because that was always my favorite character on Star Trek. And then let's go ahead and use that. So let's go back up here. Remember when we ran that command with Jesse? So we're going to edit it again. Let's get rid of the read only. And let's go ahead and get rid of this part here and put in the word data. So Docker run, we're going to remove it. For the volume, we're going to say data and put it on /mount. And before we hit enter, let me just answer this question. You're like, well, how does Docker know that I'm referring to a volume and not the local file system? And that's the leading slash. If you've got a thing that starts with the slash, you're referring to an absolute path in the local file system. If you don't have a leading slash, you're referring to a container, or a Docker volume, rather. And it will create those volumes for you automatically. But I was explicit here and created it first. And so we're going to just mount this. And here we are. Let's go to mount. And there's nothing in there. And that's because we created a new volume. It's empty. So let's put the date in a file called A. So cat A. There's our date. And let's go ahead and exit out. Okay, so we've quit. So normally when you exit out the container and the container disappears, it's deleted, all that data is gone. But in /mount, I mounted a volume. So if I go up and run this container again, just run the same command again. And I go, and go ahead and try to pull up your history, kick yourself, type cd /mount, and there's A. So A was not stored in the container, it was stored in a volume. And then if I cat A, I've got stuff in there. So you can do weird stuff with this. For example, maybe you have some, I created a container that generates a self-signed cert, which is a lot harder than it sounds. And so it automatically generates a self-signed cert. And the idea is I can include this in other projects which need internal security or need to have, present some sort of encrypted interface outside. And I didn't want to use a commercial cert for whatever reason. So it just generates a cert and automatically stuffs it in the volume. So the idea is I include the self-signed cert container in my constellation of containers I'm running for a service. And it fires up, generates a cert, stores it on a volume, exits. And in my other containers, I have the same volume mounted. So that's a neat trick. You have the same volume mounted in multiple places simultaneously. Not a good thing to do with database servers. But fine with, say, a web server or something like that. Maybe you've got a fleet of servers that are servicing the website, maybe a management interface over here and a production interface over there, and they all work in the same file system. And so your production interface has a read-only view of it. Your management interface has a read-write view. I have a website that I manage that has, I run a small SFTP server. So the web developer can SFTP in, access the web root, and access all those files on there. But it's just running as a collection of containers on that machine, independently of other services that are running on that machine, which all apparently think they own the whole machine. Do you have a question?
Yeah, where is that volume?
That's a good question. It's magic. No. Right now, sorry, I'm exiting out of the container really quick. The volume is kind of automagically stored locally. But this is it's an abstract interface, so you can say use this driver to store it using this service in this place and things like that. But if you want to see what's going on, you can use Docker volume, inspect, and then give it the volume name. And we called it data. And it'll pump out a little bit of stuff. So it says, here's the name of the container, here's the driver, this is the local driver, and here's that spot. So if we do ls on that directory, it won't let us because we do not have permissions. But we all know how to use sudo, and there it is. You can see the contents of that directory, and there's that file A that we created. But it depends on what driver you're using and where that data is actually backed, where it's stored. So it could be an NFS mount or something like that. Does that answer your question?
Can we limit the size of the volume so it doesn't use a whole file system?
Yeah, I'm not sure with the local volume. That's a good question. I hadn't considered that. I know with the volume drivers, like GFS, you can do that, and And that's where I've looked previously, was playing on GFS Docker integration. Don't know, and yeah, I can't answer that. It's a good question though. Ask me afterwards and we can explore it and see if I find a solution. Okay, let's see my examples. Okay, so let's just do a little bit of Docker cleanup. So Docker volume, and I'm just going to remove the data volume. So if this volume is being used, it will complain and say, you can't remove this until you quit the things that depend upon it. But if it's not being used, then you can just remove it and Docker volume ls, and you see it's gone back. So this is important. For example, you're rerunning your container over and over as you're going through some test cycles. It's like, okay, my data's gone bad. I need to reset. And so now you can just remove the volume, recreate it, it's empty, and then start again. So let's just do a little bit of cleanup. Docker kill db server. So this is how you stop a running container, is you can kill it. Or actually, I think you can type docker stop, which is probably a little more friendly. Let's see. Yep, docker stop. It says please first. Docker kill, just fine. These commands might take a little while, take 10 seconds or so to run. And the reason why is there's signal handling, and if your containers are written kind of badly and they don't get the signals to exit, the Docker will kind of send a stop, wait 10 seconds, doesn't stop, then it'll go and move on to a kill, and then it'll force all those processes down. So if you're having weirdness, if your containers are taking a long time to stop, go ahead and look into signal handling and Docker. Just Google those things and then get very tired and sleepy. Okay, it's not the most exciting thing, but it is important. But I won't be covering that. So Docker PS. You see we don't have anything running. Docker PS all. We see we have a bunch of stop things. So what I'm going to do is do a Docker remove db server. So now Docker PS all. And we see our DB server is gone. For the heck of it, we had this sleep right here, and I called it Jesse. Let's see, do I use that container again? No, we can remove Jesse. So let's go ahead and Docker remove Jesse. That'll make it cleaner. Docker PS all. Let's see, do we need any of these? No, let's go ahead. Your container probably has a different name. Mine is called Romantic Murdoch. I think the second part, the first part is like a sentiment or an emotion. And the second part, I think, are famous people from development. I think there's a Murdoch kernel developer, if not mistaken. So you'll see a lot of notable programmers as that second name. Okay, so let's see. Do I have any other things I want to clean up? Yeah, I'll get rid of Dr. Saha, Pricklish Saha. Okay, so now we're playing. Okay, does anybody need a break? I've been talking too much constantly for an hour, so I can talk longer. People good? Want to get more pizza?
Yeah.
Good? Cool. So now we start getting into the interesting stuff.